right, so as you're getting your 6.3 notes out, I'm going to go ahead and scroll back to the beginning of our notes packet so we can see our flow chart. Remember, everything we're talking about in this unit is a four-sided shape, which is a quadrilateral. Yesterday, we went into the parallelogram branch of this flow chart. Everything we're going to talk about today is a kind of parallelogram. So we're going to have parallelograms that have extra properties and make them fancy parallelograms. So today is Fancy Parallelogram Day. I'm going to write that up here. These are all fancy parallelograms. The first fancy parallelogram is a rectangle. What makes it a fancy parallelogram is at its core, it still is a parallelogram, which it means it has all of the parallelogram properties. I'm going to mark this diagram of a rectangle up as though it was a parallelogram. We know that the opposite sides are parallel. Oops. We know that the opposite sides are congruent. We know opposite angles are congruent. And we know that the diagonals bisect each other. Those are our parallelogram properties. What makes a parallelogram a rectangle, by definition, is that all the angles are right angles. Make sure you notate this as the definition of a rectangle. Highlight it. That's going to be important later. Oh, hello. And we can mark in our diagram 4 right angles in the corners. An additional property that we get with rectangles, that's not necessarily its definition, but is useful, is that our diagonals are congruent. So let's label these A, B, C, D. That tells me that the two segments AC and BD are congruent. Now that's a little bit different than what we said with our parallelograms. Remember with parallelograms, we said that those diagonals bisect each other. Now, because we know that they are congruent and by parallelogram properties they bisect each other, now we can actually officially say that all 4 of these pieces are congruent. So not only do we get the entire diagonal is congruent to the entire diagonal, but all 4 pieces should now be congruent. And those are our 2 rectangle properties. Let's use them in examples. So in example 1, the first rectangle property, by definition, what a rectangle is that in the corners, we get 90-degree angles. So this corner right here, 90-degree angle, I should be able to set up a nice easy equation with that 90-degree angle that says 5x minus 14 equals 4x, or not equals, plus 4x plus 5 equals 90 degrees. And simplify, 9x minus 9 equals 90. X equals 11. And then for number 2, this is going to use our second rectangle property, which is that the diagonals are congruent. So it says AC is 2x plus 3. There's AC. BD is 12 minus x. That's BD. I know that those are congruent by my rectangle properties, so I can set them equal. It is a lot of figuring out what can I set equal, what can I add together to make 90, what can I add together to make 180. That is why it is so important you're memorizing these properties. So this is 3x equals 9, where x is 3. Any questions on that? That's our first fancy parallelogram. Our second fancy parallelogram is called the rhombus. Of course, it is still a fancy parallelogram, so it gets all of my parallelogram properties. Which means I can mark this diagram with all those same things. Opposite sides parallel, opposite sides congruent, opposite angles congruent, and the diagonals bisect each other. Those are my parallelogram properties. And then by definition, what makes a parallelogram a rhombus is that all sides are congruent. So I can mark all 4 sides congruent. Additional properties that we get with a rhombus are that the diagonals are perpendicular. So when I draw in my diagonals, I can draw in a nice right angle in any of those 4 spots here in the middle. All of these are right angles. And then the last one, kind of weird because we've already talked about diagonals bisect each other. This one says diagonals bisect the angles. So if I draw in this diagonal right here, it's telling me, well, first of all, we already know by parallelogram properties that this angle and this angle are congruent. So if I bisect each of those angles, I'm cutting them into equal pieces. I get 4 equal pieces on the ends of each diagonal. If I do the same thing this way, I know opposite angles are congruent. I'm bisecting, which means I'm cutting each one in half. I get 4 congruent pieces this way. So each diagonal has 4 congruent angles on either end. Questions on rhombus? Let's use those properties. In example 1, we are using the property, the definition of rhombus, which says all 4 sides are congruent. To set up our first equation, 2x squared equals 8x plus 24. Oh no, we have to factor. I'm going to move everything to one side. So 2x squared minus 8x minus 24 equals 0. What's our first step to factor this? Dahlia? Divide by 2. Take out a GCF of 2. X squared minus 4x minus 12 equals 0. I'm going to leave that 2 in the front, and I need 2 factors. What are we thinking? Yeah, Allegra. Perfect. I need them to multiply to a 12. I need them to add to a negative 4. So I do negative 6 and positive 2. My 2 answers, when I set each piece equal to 0, x equals 6 and x equals negative 2. Am I done here? What do I still need to do before I can call it a day? Dahlia?
Check for extraneous.
Yes. We're going to check for extraneous. So that negative 2, we're going to double check it in our problem to make sure that it doesn't give me any negative side lengths. So I'm just going to plug in right here, 2 times negative 2 squared. If I square that negative 2, the negative is going to go away, so that's going to get me a positive number. That's fine. If I plug in 8 times negative 2 plus 24, am I going to get a positive number? Negative 16 plus 24 does get me a positive number. So I can say that both of these answers are okay. Any questions there? Okay, this next one. I feel like the angles are harder than the sides. So I've got, in number 2, I've got some angles. The first angle, angle 1 should be easy. What's the measure of angle 1? What's the measure of that first angle? Allegra? Yeah, exactly. Our first property for rhombus is that those diagonals are perpendicular. So in the middle, we have a 90-degree angle. Okay, what do we think about angle 2? Or 3? Yeah. Yeah. So our rhombus property that tells us that the diagonals bisect the angles, this diagonal bisects this angle and this angle. We get 4 congruent pieces. So 2 and 3 are both 50. One more piece, angle 4. I've heard a couple ways to find this already today. Anybody want to give it a go? Yeah, Aubrey. How'd you get 40?
180 minus 140 is 90 plus 50.
You use this triangle? That's what I did too. I saw there was a triangle here. I know that this angle down here is 50 degrees. I know this one was a right angle. So I added those together to get 180 to figure out that this last angle was 40. Somebody in the other class also said, I'll just show you this so that you can see what they did. But they also said that, hey, these 2 angles are supplementary. This one over here is 100. This one must be 80. If I cut 80 in half, I get 40. That's using our parallelogram properties. So maybe you did that. Other questions on rhombus before we move on? Okay, last special shape is a square. Now, squares are very, very special because if you go back to the flow chart, I won't pull it up, but if you go back to the flow chart, it's underneath rectangle and rhombus, which means that a square is a parallelogram that is both a rectangle and a rhombus. So it has all the parallelogram properties, of course. Parallelogram. So I can mark up my diagram. Opposite sides parallel. Opposite sides congruent. Opposite angles congruent. Diagonals bisect each other. By definition, it has to have all right angles are right angles. That's from the definition of a rectangle. And it also gets my other rectangle property, which is that the diagonals are congruent. So I should have 4 right angles and congruent diagonals. If I call this A, B, C, D, I know that AC is congruent to BD. Let me zoom in a little bit here, sorry. And I know that all 4 of these pieces are congruent. And then I get the rhombus properties. By definition, that means that all sides are congruent. So a square has 2 definitions, all right angles, all sides congruent. And then it also gets all the other rhombus properties. So all 4 sides congruent. The diagonals are perpendicular, meaning we get 4 right angles in the center. And the diagonals bisect the angles. If all of those angles are 90 degrees, what is each one of these little pieces? What is one of these? Dahlia. Exactly. And that gets us our fancy schmancy square. Any questions on this? Let's take a look at square examples. This one is not written. It says, find the measure of angle DAC and X if the measure of angle BAC is 3X. First of all, what's the measure of angle DAC right there? Without doing too much work, we can figure out what that angle measure is. What is the angle measure of DAC? Anybody? Anybody? I just told you like 30 seconds ago. It's 45. Every little angle in the corner here is 45 degrees. So the measure of angle DAC is 45. So when I say the measure of BAC is 3x, here's where BAC is. We also know that that is 45 because they're congruent. So the measure of angle BAC is 3x. Well, then 3x must equal 45, and x is 15. Number 2, if the measure of angle AEB, here's AEB, is 6x plus 24, find x. What does AEB have to add up to? Or equal, Caitlin? Yeah, 6x plus 24 equals 90. 6x equals, I'm subtracting 24, that's 66. Or x equals 11. Done with that diagram now. I'm going to move away from it. If AE equals 2x plus 4 and BD equals 8x minus 4, find AC. So let's highlight here. AE is 2x plus 4. BD is 8x plus 4. Oh, hello. What's my equation for this? Any ideas? Squares have a lot of properties. I know the diagonals are congruent. I know the diagonals bisect each other. So I should be able to tell that for a square, all 4 of these pieces are congruent. So my equation is going to look like the whole thing, 8x plus 4, 8x minus 4, equals 2 of these smaller segments put together, 2x plus 4 times 2. So 8x minus 4 equals 4x plus 8, which is 4x equals 12 or x equals 3. Do not forget to read your directions completely. We have to go back and find AC. AC is 2x plus 4s, or you know that AC and BD are congruent, so you can just say that AC is BD, which is the same as 8 times 3 minus 4, which is 20. Questions on that? Okay, I'm sorry, we're not done. We have an extra page. Flip it over. We did this with parallelograms. Now we're going to do it with all 3 of these shapes. We are under the assumption already that all of these shapes are parallelograms. So we're not going to need to prove that the opposite sides are parallel like we did yesterday with our parallelograms. But if I take a look at number 4, it says, show that KARI is a rectangle. I'm going to need to prove the definition of a rectangle, which if you go back and look, the definition of a rectangle is that I have 4 right angles. So let's start by graphing KARI. I have 2, 1, 4, 4, 10, 0, and 8, negative 3. And you're thinking, hey, Miss Lise, that kind of looks like a rectangle. I don't know. And you would be right. It does look like a rectangle. But we got to prove it. How are we going to prove that this shape has right angles? Dahlia?
Opposite and then negative slopes.
Opposite reciprocal slopes. Basically, what we're trying to prove is that those lines are perpendicular to one another by getting opposite reciprocal slopes. So that's what I'm looking for here. I'm going to figure out the slopes of all 4 of these lines. So let's start with the slope of KA. And I'm going to count rise over run. I won't do this every single time, but I'm going to do it this time. The rise is 3, the run is 2. Same thing for the rest. The slope of AR, I'm going down 4 over 6. And we're going to simplify that, negative 2 over 3. Hey, those look like opposite reciprocals to me. Let's check RI. Remember, when we count slope, you want to start from the left point. So start with I. Go to R. So up 3 over 2. And then lastly, the measure of KI is down 4 over 6, reduced to negative 2/3. So would we say we have a rectangle here? I think yes. Yes, because we have 4 perpendicular lines. Okay, next. Now I want to prove something is a rhombus. By definition, what do I need to know if it's a rhombus? It has what? What does a rhombus have? Caitlin? Yep, 4 congruent sides. Go away. So let's plot ABCD. Negative 3, 2. Negative 2, 6. 2, 7. 3. And again, you're like, Miss Lisa, that looks like a rhombus. Can we just say it's a rhombus? How are we going to prove that these sides are congruent? Let's start with AB. How do I figure out how long AB is? Oh boy, we got to go back to like unit 2 when we did this. Do you remember how we did right triangles? Yeah, Pythagorean theorem with our right triangles. If I draw up a right triangle, my right triangle has side lengths of 1 and 4. So my hypotenuse, the length of AB, must be 1 squared plus 4 squared equals c squared. I'm going to spare you all the work I did in my calculator, but we get the square root of 17. And now I already know that this is a parallelogram. So I already can assume that CD is the same. So CD is also the square root of 17. What I need to prove is that one of the other sides is also equal to the square root of 17. So I'm trying to save you a little bit of work here by not having to plug this in for every single one because we already know the opposites. So let's do BC. And again, I draw my right triangle. Hey, look, that has side lengths of 1 and 4. We're going to get the exact same thing, square root of 17. And I know that because it's already a parallelogram, my opposite sides are going to be congruent. So BC and AD are the same. Those are 4 congruent sides. This is a rhombus. All right, here's the big one. Now we need to prove that something is a square. So for this to be a square, I need both of those previous things to be true. I'm going to kind of draw a line in the middle here. We need some room. The first thing that I need to prove is that this has 4 right angles. That's going to tell me that this is in fact a rectangle. And then after I prove that it's a rectangle, then I'm going to go and figure out, does it have 4 congruent sides, which will tell me whether or not it is a rhombus. So let's plot our supposed square at negative 1, 0, 3, 3, 6, negative 1, and 2, negative 4. Looks pretty square to me. Let's figure out our slopes so that we can figure out if our sides are perpendicular. So the slope of DA, up 3 over 4. The slope of AN, down 4 over 3. The slope of CN, up 3 over 4. And the slope of DC, which is down 4 over 3. Do we have a rectangle? Yes. Now I got to do the same thing for rhombus. Well, not the same thing. What is a trick here that I think some of you are going to see and some of you are maybe not going to see is we pretty much already did right triangles when I calculated rise over run. So you can use the values that you put in your slopes as long as you haven't simplified your slope yet. So remember up here, the lengths of these sides were 4 over 6, not 2 over 3. So you got to make sure that you use the unsimplified version if you're just going to do that. Otherwise, we can just count. If it makes more sense to you to count, this is 3, this is 4. So for the length of AD, I have 3 squared plus 4 squared equals C squared. C is going to equal 5. AD is the same thing as CN. So I have 2 congruent sides right now. I got to find the other one. DC is 4 squared plus 3 squared equals C squared. That also gives me a 5. And we know that's the same thing as AN. So is this a rhombus? Yes. So to say that this is a square, we would say yes, it is a rectangle and a rhombus. Beautiful, beautiful, beautiful. We did it. I'm going to switch back to the, I don't want these right now. I'm going to switch back to, if I can see it, there it is, the checklist. Let's just fill that in really quick. So parallelograms have the same properties. So rectangles, rhombus, square, all fall under the parallelogram category. So all the properties that a parallelogram has, rectangle, rhombus, square also gets those properties. In the second column, a rectangle, by definition, has 4 right angles. An additional property, we get the diagonals are congruent. In the third column, a rhombus doesn't have those properties, but by definition, all sides are congruent. We also get the diagonals are perpendicular, and the diagonals bisect the angles. And then guess what? For a square, it's a parallelogram, it's a rectangle, it's a rhombus. We get all those properties. And there we go. That's filled in. I know that was a long one. Your homework is on Math Lab. You got about 15 minutes to get it done.